In this lesson, we're going to learn how to find distance from a point to a line. So far up to this point, we've always found distance from one point to another point, so using distance formula, counting, or using Pythagorean theorem. So now we're going to look at what happens if we look from one point to a line. How do we find that distance? So the first example here, go ahead and plot the point. So we have 2, 5. So 2, 1, 2, 3, 4, 5. Label that point P. And then if you look at these lines for A and B, these are both x equals numbers. So these are going to be your vertical lines. And then these two, y equal numbers, these are going to be horizontal lines when you go to graph these. So these are kind of like your exceptions. They're not in y equals mx plus b form, but they're, if you look at x equals -5, what that really means is I go to -5 on the x-axis, so 1, 2, 3, 4, 5, and I want to represent all of the x values that equal 5. Y is going to change, but x will always equal 5. So it's going to be a vertical line because on this line, all of those points, y is changing, but x always equals -5. So that's why those are always going to be vertical versus y equals will always be horizontal. So then if we want to find the distance from this point P to the line x equals -5, hopefully you agree that there's multiple distances that you could find. There's multiple ways that you could find this. You could go from point P to here. You could go this direction. There's lots of possible distances that you can find from point P to x equals -5. However, the problem would be if we just didn't worry about a process or a rule that we always follow from finding the distance from a point to a line. Everyone will be getting different distances. It's not consistent. So what we do to ensure that we'll always have the same distances is that we always measure that distance from a point to a line. We always measure it so that we're perpendicular to the segment. So if you look, let's put a star by this or bubble it in. This is an important concept here, that whenever you're measuring the distance from a point to a line, we always have to measure the perpendicular distance. So that means I really care about from point to this line, I care about this distance right here, that perfectly horizontal line that would measure the distance. So for this, in this case, I can just count it out. So 1, 2, 3, 4, 5, 6, 7 for that. And then if we do the same thing, but for x equals 6, well, now you're going to go over to 6 on the x-axis. So 2, 4, 6. You're going to draw a line through that. So here's my line, x equals 6. And then if you go to count the distance, well, from point P to this line, we want the perpendicular distance. So it's going to be the horizontal line that goes between point P and x equals 6. And that has a length of 1, 2, 3, 4. You can also look here, if you look at the change in the x value, so since it's -5 was the x value, and look at the point 2, that change was 7, and then same thing here, from 2 to 6 was 4, so that's the distance. So the same idea for y equals, it just means that now our lines are going to be horizontal. So let me go ahead and sketch that. So y equals 8 is going to be up at 8 on the y-axis, so 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to draw a horizontal line, because remember, this really, if you were thinking of this in y equals mx plus b form, this really has a slope of 0, so that's why you only see the y-intercept. So this is y equals 8. And then now if you're measuring to point P, you're measuring the vertical line because you're measuring perpendicular to the horizontal line, and there's 3 units there, so this distance is 3. And then y equals -1 is the last line that we're looking at here. So we have y equals -1 on the y-axis. And then draw your horizontal line going through that. Again, remember, on this line, the x values are changing, but y always equals -1, which is why it's horizontal. Also, the slope is 0. So then the distance from point P to there, you're measuring, so 1, 2, 3, 4, 5, 6. So that's going to be 6. And for this case, you would compare the y value, since you're looking at y equals, and you see that there's a distance of 6. So when you have horizontal and vertical lines, it makes it easy to find the distance from a point to one of those lines, because If you're starting with a vertical line, perpendicular to it will always be the horizontal, and you can just count it out. Or vice versa with, if you start with a horizontal, then you'll be finding a vertical distance. The problem is going to be what happens when you start out with a line other than a vertical or horizontal line. So for example 2, we want to find the distance from point Q to this line right here. So let's start by graphing that and plotting this point so that we can kind of see what's going on here. So when we graph this line, my slope is going to be 1, my y-intercept is 5. So I'm going to start up at 5, so 1, 2, 3, 4, 5. And then I'm going up 1, right 1, because it's positive 1 over 1. And then go backwards, down 1, left 1. Once you get enough points plotted, go ahead and use your straight edge and connect those. And we'll just label it. So this is going to be y equals x plus 5. And then we have our point Q. So 5, comma 3. So 1, 2, 3, 4, 5. 1, 2, 3. And there's my point. So hopefully already you can see that I can't count this distance. It's not going to be the same as just going ahead and counting perpendicular to this. But the good thing is you already know how to find a line that's perpendicular to y equals x plus 5 and passes through a given point. We've done this already a couple lessons ago, where if you want to find an equation of a line that's perpendicular to a given line passing through a given point, you can use point slope formula to do that. So that's kind of our goal here. If we find a line, first of all, that's perpendicular passing through Q, then what we'll have to do is we'll have to find that distance between point Q and the point of intersection. So that's kind of our goal. So this is kind of as complicated as it gets for these types of problems, just because now you have diagonal lines, so you can't just count it out. But good news is you kind of already know how to do it. So we already did part A. So we are going to be finding this distance. We don't have QR yet because we don't know where R is, so I'm going to wait to label that. But we're going to go ahead and come up with the equation of this new line, QR. So remember, we have our point slope formula. So y minus y1 equals m times x minus x1. I know the point that my line has to pass through Q. So I'm going to use that. And I know my slope. My slope of the original was 1. So the perpendicular slope, if you flip and negate negative 1 or positive 1 over 1, it's going to become negative 1 over 1. So my perpendicular slope I know. And I know my point, so I can go ahead and plug those in. So I have y minus 3 equals negative 1 times x minus 5. And then I'm going to go ahead, I'm just going to go ahead and get this into y equals mx plus b form. So I have negative x plus 5, bring the 3 over. So we have y equals negative x and then plus 8. So here's my equation. So if we actually went and graphed that, so we'd be up at 5, 6, 7, 8, and down 1 over 1, down 1 over 1. I'm going to go ahead and connect these. So this is my line right here that I just came up with. It's the perpendicular line passing through point Q. What I care about is this solution, or this intersection, because that intersection I'm going to call point R, and then I'm going to be able to find the distance between Q and R. And then that right there is my perpendicular distance between the point and the given line. So in order to find that point R, I'm going to use my graphing calculator. So if you don't have your graphing calculator, pause the video, grab that, and then we'll go ahead and get started on graphing. Now you could also solve the system algebraically, but it's going to be just quicker to find the intersection right on the graph, since we already are looking at a graph for this type of problem. So it's really kind of your call, but you do have to find the coordinates so that you can then find the distance. So I'm going to go ahead and graph y equals negative x plus 8 and my original, y equals x plus 5, and I want to find the solution. So I'm going to just say from the calculator. So let's go ahead and look at that. So on the calculator here, I'm going to my home screen, go down to the graph, And we're going to go ahead and type in the first one. So I had the negative x plus 8. Hit enter. And then we're going to type in the second one here. Is x plus 5. And then I'm just going to move this intersection so I see it right there, but I'm going to move that so I can see it a little bit better. So I'm just going to go to Window, Zoom. If you go to Zoom in, and then your center is right here. So that kind of just allows you to get a better view of the intersection. And then what we want to do is we want to find the intersection. So it's Menu, and then Analyze Graph. Because anytime you want information from the graph, most likely it's under Analyze Graph, and then go to your intersection. So your left side, and then just shade over until you see the intersection. So here's my point. So I'm going to go ahead and write that down. So 1.5 comma 6.5. So my solution from the calculator was 1.5 comma 6.5. And then that tells me that up here on my graph, this is 1.5 comma 6.5. So now all I have to do is find the distance between that coordinate and what I already know is q, which is 5 comma 3. So using distance formula would be the way to do this, or you could use Pythagorean theorem if you wanted, but I think that'll make the graph look pretty crowded. So I'm going to go ahead and just use distance formula. So now it turns into another problem that you've already seen. So basically this process was just kind of piecing together different things that you've already done into solving a new process. So I have my distance formula, and then we're plugging in. So let me just record the points again that I'm using. So I'm using Q, which is 5, 3, and R, which is the 1.5 comma 6.5 as my coordinates. So I'm taking my x2, so let me just use 5 first. So 5 minus 1.5 squared plus 3 minus 6.5 squared. And then really at this stage, you could just put this whole thing here into the calculator. So when I do that, I got 24.5. And then we're rounding to the nearest hundredth. So our answer, square root that. And I got 4.95. So QR to the nearest hundredths would be 2 decimal places, so 4.95. So that would be my answer. So that's your process that you're doing. So if it's vertical and horizontal lines you're dealing with, you can just count those. Otherwise, if it's diagonal, then this is the process that you'll always run through. Find the perpendicular line that passes through that point. Find the intersection so that you know what point you're using now, and then you turn it into a problem where you're really just finding the distance between 2 points, and then you just use distance formula for that. So from here, now you can go ahead and do the check your understanding problems on the next page.